Welcome back to the last week of Algebra 1. We're going to finish off with solving rational equations, but in order to do that, we need to remember our most useful method for solving problems that have fractions. So try to solve these, and in solving these, remember we would like to get rid of the fractions first. Please try them. So hopefully what you got on these for problem 1 was 2, problem 2, 4, problem 3, 12, and problem 4, 28. So how do we solve these types of problems? We look for the least common denominator. So in each of these, I'm going to look at the denominators, and 2 and 3 both go into 6. So I'm going to multiply every single term in my problem by 6. And when I do that, I'm going to end up getting a problem that doesn't have a fraction in it. So in this one, what I ended up solving was 3x plus 6. Now, let's back up a little bit and see how we get that. So 6 goes into 2 3 times. So what I'm multiplying is 3 times x plus 2. In my second part of this, 3 goes into 6 twice. So on this one, it's 2 times x plus 4. And 6 doesn't go into anything, so in this case I have 24 as a final answer. Now, it turned out that 2 times 3 was my least common denominator, but that's not always the case. In the second problem that we have here, we notice that 2 goes into 8, so my least common denominator is actually 8. So I'm going to multiply every term by 8. And I like to simplify things when I can. So what I notice is 2 goes into 8 4 times. 8 goes into 8 all the way. That gives me a 1. So I end up with the problem that I'm solving is 4 times x plus 2. That has to be in parentheses. That's important. Now, since this simplified to a 1, I don't have to write 1 parentheses. I can just write x plus 4. And the other side of my problem is a 32. Now, pretty much the same thing happens here in problem 3, so I'm going to end up having 8 as my least common denominator, and I'm going to end up with 4 times x plus 2, and I'm not going to put parentheses around this. If I did, I would determine that they were unnecessary. But this side is going to be 8 times 9, which is 72. Now, my last problem here shows me that sometimes my least common denominator kind of has a part of both of these problems. So if I take a look at 6 and 8, now they do go into 48, but they also go into something a little bit smaller, 24. So I'm going to do 24 as my least common denominator. And I just kind of try to chicken scratch these in. If you're writing it out, I'd definitely write it out a little bit better. But I'm just trying to show where we are multiplying by 24. Now, 6 goes into 24 4 times. 8 goes into 24 3 times. So what I end up having for my problem to start with here is 4 times my first numerator, and notice it's in parentheses. Now this time my second one is also multiplied by 3. And guess what? My other side of the problem, it can get big, because this is going to be 24 times 9. That's okay. It's not a fraction. So we'll deal with the big numbers. It's not a fraction. It'll be easier to deal with. We're going to use this exact same method in problems that are rational equations, which means I can have a variable in the denominator. So we're going to use the I hate fraction methods on rational equations. Variables in the denominator. So when I have variables in the denominator, I'm still going to look for my least common denominator. It just might have a variable in it. So if I look at these 3 denominators, they all have 3 in them, so I know that 3 is going to be part of it. But then m squared, well, they are all going to include m squared. So my least common denominator is 3m squared. That means I have to multiply the entire equation, and just to make it look a little bit neater, we're just going to do it this way. Now the problem with doing it this way is I like to cancel things before I do the multiplication, and sometimes we lose track of what we're canceling out. So m squared divided by m squared, I'm going to be left with 3 times 3 on this side of the problem. 3m squared divided by 3m squared, well, that goes away. And 3m squared divided by 3m squared. So I end up with a simpler Algebra 1 problem. Now I'm going to simplify that. And solve. So in this case, m is 11. Okay? Least common denominator can include variables, can include a squared variable. So in this case, what's my least common denominator? This guy has an x, there's an x in here, it's multiplied, so it's going to be a 4x. Now I am going to write it out. With each term. Because if I write it out with each term, I can cancel everything that I need to cancel, and I won't lose track of it for the next thing. So here it is written out, and then the next step is cancel every part of that least common denominator that I can. In this case, x goes away, but in this case, 4x goes away. So what do I have left? I have 4 times 1 minus 4x times 1 equals 3. And I work on solving that problem. Never lose our negative signs. This becomes negative 1. Then I'm going to divide by negative 4. And x equals 1/4. And I want to see that as a fraction. Do not be afraid of fractions. Okay, again, I'm looking for my least common denominator. I've got an x goes into 5x, 5x goes into 5x. So my least common denominator, the thing that I'm going to multiply everything by, is 5x. So I can either write this one whole thing with the entire equation inside it. I also can write it with the parentheses, one for each side. Both of those ways are perfectly okay. Now I don't want to just cancel this and then ignore it for the next term. For every single new term, I have to go, okay, back to the least common denominator, what cancels? So on my first term, x cancels. That gives me 5 times x minus 4. Notice that I'm putting the numerator in parentheses. Now I have a plus sign. Least common denominator again. 5x divided by 5x gives me 1. 1 times 1 is 1. 5x divided by 5x gives me 1. So because I'm not multiplying this by anything, I didn't write parentheses around it. Now, distribution. So I have 5x minus 20. Now I'm going to subtract x from both sides. That's going to give me 4x. Now this is a place for a real common mistake. That's because the negative sign goes with the 20. And we forget about that negative sign meaning negative 20, not positive 20. If I owe somebody $20 and I only have $1 to pay them, I still owe them 19. It's a real common place to forget about that negative sign. Sometimes people write down the negative and then they do 20 plus 1. And unfortunately that's wrong. Also, this negative sign needs to stay here. So my next step is going to be add 19 to both sides, which is going to give me 13. And there is no reason to grab a calculator because we're dividing by 4, because we have a fraction. That fraction doesn't simplify. They're not divisible by 2 or 4. So we're going to leave it as a final answer. And the only thing that you would do if you want it as a decimal is just grab a calculator. Why bother? It's easier to leave it as a fraction. Okay, least common denominator. Of my numbers, 1, 4, and 2, everything goes into 4. Of my variables, x squared and x, everything goes into x squared. So my least common denominator is 4x squared. And if I write that once on each side, now 4x squared divided by x squared gives me 4. And then that is multiplied by the numerator of that term in parentheses. Notice I have a subtraction sign this time. 4x squared divided by 4x squared, oh, that's 1. 1 times 5 is 1, 5. 1 times 5 is 5. Then when I divide these guys, I do get something a little different here. 2 goes into 4 2 times. This time x doesn't cancel the x. It cancels the square. It gives me 1x instead of xx. So on here I have 2x times 1. So 2x times 1 is 2x. Now I can simplify that by distribution. And then we're solving the algebra problem. So in this case I do have positive 16 minus 5, so that's 11. Now 8x is the bigger x, but it's on the side that has the constant term to it. So if I just subtract 8x and deal with the negative signs, I'll be able to get to the same place without quite as many steps. So we have, now I'm not going to write the plus because I've already checked that. So if I have a negative sign, I have to keep writing it. If I have a plus sign, I don't. Dividing by negative 6. So x equals, and no sense grabbing a calculator. I do not like negative signs in the denominator. Negative in front or on top. Those are equivalent to this, but we don't say 11 divided by negative 6. We say negative 11 sixths. So both of these we would write, we would say that way. So that's what we want to do. Least common denominator is 2k. So you can write it out once, but you have to. Oh, there's nothing to divide here, so this just becomes 2k. That 1 is still important. 2k divided by 2k is 1 times 5, and 1 over here. Subtracting 5. Once we do the I hate fractions method, we are back to the things we did in the first semester of Algebra 1. So my least common denominator is going to be 3n. N goes into 3n. There's nothing in the denominator, that's okay. 3n divided by 3n, 1 times 1 is 1. 3n divided by n. That cancels the n, so this one is 3 times 2. Plus, I don't have anything to cancel, this becomes 2 times 3n. So I'm going to subtract 6. I get negative 5. Dividing by 6, and if you divided this and rounded it, it would be wrong. Do not want you to write a decimal when your fraction changes to a decimal that doesn't end. Terminal decimals I tolerate. Non-terminal decimals I don't. Negative 5/6. That's what we're doing, guys. So your assignment today, you have a worksheet, and then tomorrow's we will add some additional problems that are a little bit harder. Have a good day.